we had looked at a priori algorithm, and we said the algorithm, we had looked at a priori algorithm, and we said that the algorithm is used to mine frequent pattern or frequent item sets by iteratively pruning until you arrive at the most occurring frequent pattern sets. Then we introduced, that is a priori, then we introduced the frequent pattern growth, of which we said this one use a tree-like structure where you continue mining for frequent item set until you are certain that that is the result that you definitely need. Now, in our last algorithm, we discussed about a priori algorithm, ways to enhance its efficiency, its advantages and disadvantages. And some common disadvantages we touched on include that using a priori needs a generation of candidate item sets. And when these item sets are large in number, the item sets may be large in number if the database is huge. Then a priori needs multiple scans. Iteratively means that you do it over and over again until we arrive by pruning and evaluating against the support and confidence. Now, when we come to frequent pattern growth now today, this one it represents the database in the form of a tree called a frequent pattern tree or FP tree. A frequent pattern is generated without the need for candidate generation. So the database is fragmented using one frequent item. The frequent pattern is called the pattern fragment. And when after these patterns have been fragmented or have been grouped together naturally and dynamically, they can then be analyzed. Thus, with this method, the search of frequent item set is reduced comparatively. So we reduce them comparing with the previous one. Then we also have what is called an FP tree, which is a tree-like structure that is made with the initial item sets of the database. So at the root of the tree is a null box, and then from then we look at the most frequently occurring item, or the item with the largest number of the item with the largest number of occurrences or support. Then it aims at mining the most frequent pattern. Each node of the tree represents the item of the item set. The root node represents null, while the lower nodes represents the item sets themselves. Then the association of the nodes with the lower nodes, that is the item sets with the other item sets, are maintained while forming the tree. So the steps, number one step, you scan the database to find the occurrences of the item sets in the database. And this is the same as the first step in the a priori algorithm. So we look at transaction 1, look at transaction 2, all the way up to the last transaction. Then we say the confidence of 60% implies that if the the transaction T1 has product I1, then there is 60% chance that product T2 will also have item. Not item I1. If transaction T1 has a frequently occurring item set, then it is 60% likely that transaction T2 will also have items contained in T1. So the same thing until we reach the T6. That is basically what we are trying to say. But first things first, we scan the database to find the occurrences of the items in the database. We must first of all have a threshold, a support threshold, also a confidence. So confidence is taken as 60 and support threshold is taken as 50. So the support threshold is actually like a single item for all the transactions. In how many, like what is the percentage? What percentage is sure that in all the transactions a single item might appear how many times? So when we say the minimum support is equal to 3, it means that a single item might appear 3 times in the 6 transactions, and that is what is called the support threshold of 50%. So a single item might appear 3 times in all the 6 transactions. That's 50%. So you say the number of the minimum number of item set that a single item might appear all over the total number of transactions. And when you do that, you end up with 3. Then the confidence, what did we say? The confidence of 6%, we say there is a 60% chance that whatever we had in transaction 1 might also be contained, the same item set, or a single, or at least an item might be contained in another transaction. So when we do that, we find the count and we delete the one that do not meet the support threshold, then arrange in descending order. So we remain with I2, I1, I3, then I4. Focus a lot on I2, then build the frequent pattern growth tree. We first of all consider the root node null. Then the first scan of transaction T1, I1, I2, I3 contains 3 item sets. I1 has 1 item, I2 has 1 item. I2 appears once, then I3 also appears once. Now, because I2 is the most frequently has the highest number of support, then definitely it is going to be linked to the root node. Then the one that follows, which is I1, is linked to the I2. Then I3 will be linked to I1, and so on. That is, if they are in the same transaction. We are still looking at transaction T1. So I2, which has the highest number of support, is actually linked to the root node. Then after that, the one that follows is linked to it. Then the one that follows I2 is also linked to the one that follows I2. So yes, may you kindly come up again? I think I lost you somewhere. Yes, yes. Mm. Yeah, they will just follow like a sequence, and I think what they've used here is just some common sense that when I2 has a higher value and I1 and I3 and I4, look at I1, I3, and I4 actually has the same value, then it means 1 should come before 3. That is just some logically speaking, but I don't think if it will still hurt if you start with I3, because at the end of the day they are still 4. But it will still lead you to the same thing, to the same to the same item set, and you're going to see the tree. Yeah, and it's just that the mode of arrangement, this guy tried as much as he can to follow a 1, 2, 3, 4 sequence, and now that I2 had the highest number, it had to come on top. I think lakini hizo zingine they shared, then 1, 3, 4 had just to follow each other. Well, I get what you mean, but it follows a sequence. It doesn't matter what item it is. So it just follows a sequence. At the end of the day, we don't care about the position of the item. I want just placeholder. What if the item itself is a Colgate? Then another one is a jacket. So are you trying to say that a Colgate must come before jacket? No, it's just your own arrangement. I think I've answered your question. Yeah. So there is no explicit, just a sequence, but there is no explicit way to say that this one must come before this because they tie. No, the guy has just tried to be logically. It's also, I don't know what kind of disease it is, but it's a disease. There's some people who cannot put I3 before I1, and even if even if they put the place I2 at the top because it has the highest number in our Umasana, but they're just being forced. And I the perfectionist guys. But just to answer you, there is no problem. You can just alter them the way you want. At the end of the day, it will still give you the items that you want. It's just that the arrangement will be slightly different, but the items will contain the same things that like mine. to just scan transaction T1. Let's now go to transaction T2. T2 contains I2, I3, and I4. But I2 was linked to the root, then definitely I3 will be linked to I2. I think as we do that, let us draw the tree. The first transaction of the first set scan of transaction T1 contains items I1, I2, and 3. And because I2 is linked as a child to root, since it has the highest, the largest support, then I1 will be linked to I2 and I3 will link to, like, I want to form a sequence at 3, that is. So look at that. We have the root node as null, then I2 as 5 and is linked to null. Then I1 is linked to I5. And remember, as at now, I1 is 1. So let us also draw ours as we move along. At the end of the day, this is an aggregation. I think you are getting the point now. But the aggregation must scan through the database. So it will start with 1, then it keeps on appending. So I2 as 5. Then from I2 we said is I1. I just want to start with 1 for now. Then after I1 we append I3, which is also 1. So at the end of the day, we end up with something like that. We look at that frequent pattern. Then let's move to the next transaction T2, which contains I2, I3, I4. But I2 is linked to root. So I2, I think mambo yake imeisha. Then I3 is linked to I2 and I4 is linked to I3. So I3 is linked to I2. I3 is because there is no I1 here. So when I3 is linked to I2, then it means we go back to the tree and link to I2. But remember, this part here is now transaction T2, but while this one was transaction 1. But transaction T2 did not contain item 1, so there is no aggregation. So we put here 1. And because transaction T2 did not have I1, we do not aggregate the one with transaction 1. Yes. So that's the same way we move. So let's go to the other one. Then I4 is linked to I3. Because there is I3 here in transaction T2, then I4 is linked to I3. Na bado ni 1. Remember, E1 is the number of occurrences in that specific item set. So if it is occurring more than once, like here, if it's going to here, in this T1 up to T6, if we add I1, I2, I2, I3, then we're definitely going to say I2 to 2. But for now, they're just occurring once. Yeah. Then, but this branch will share I2 node as common as it is already used in T1. Increment the count of I2 by 1 and I3 linked, and I3 is linked as a child. Actually, as we moved on, we were supposed to be incrementing so that we do not land into an error. So here was 1. So here was 1. Yeah. Now when we move back to our frequent pattern, we are being told that I2 contained, remember transaction I1 contained I2, and that was 1. Sindio? Transaction I2 also contained I2, so you come back here and increment plus 1. As we move along, now let's continue. Then increment the count, and I3 is linked as a child to I2, I4 is linked as a child to I3. So at the end of the day, we have the following count: I2 2, I3 1, and I4 1. Transaction transaction 3 contains I4 and I5, which means that there is a branch which must be created. So look at that. It means that if transaction 3 contains I4 and I5, then it means that I5 can proceed from I4, which means a new branch with I5 is linked to I4 as a child is created. So a branch from I4, so we link it that way. Just come here and link I5, 1. Yes. We are going to see how the one from null comes about, but let us still move on. Then transaction 4. It contains I1, I2, I4. The sequence will be I2, I1, and I4. I2 is already linked to the root node. So instead of relinking again, what we do, we increment. So we just go to I2 wherever it is because it is contained transaction 4. Then we increment it there. Then the same thing will happen. In transaction 4, the sequence will be I2, I1, and I4, which means that I1 should proceed from I2, and it is already proceeding. So we do not need to proceed again another one, but just increment. So this root here is going to contain two transactions, transaction 1 and transaction 4. Tuko pamoja? That is what I was missing the other day. The other day I was trying to force each transaction to be in this wrong path, which cannot happen. Then we have I4. That is transaction 4 contains I1, I2, and I4. The sequence will be I4 does not proceed from I2. So when I4 does not proceed from I2, we introduce another. And remember, look at this. We cannot produce. We are going to lose something. I4 does not cannot proceed from I2, but since it is not a child to the root, it means that we are not going to consider it as a frequently occurring as far as this transaction is concerned. Maybe this person came to the database to the site and just bought something out of will, but he was not bound to buy it. So what we do in this case, we might lose it. We might find ourselves losing it. So we put it pending, EV. Tunaandika hapo I4. Then we proceed with the others. Transaction I5 contains I1, I2, I3, I5. The sequence will be I2, I1, I3, and I5. Thus, we increase I2 plus 1. So, then, since I1 proceeded from I2 and it is already proceeding, then it means that we just increment 1 and add another transaction 5 here. Mm-hmm. Mm. So that it proceeds from T2, I2, I1, then I4. So if you look at our tree, what you're trying to say is that we now proceed from here to get I4, 1. Then you are trying to say that this one should now form a transaction 4, that way. Remember, what we are looking at is frequently occurring, not explicit or total number of occurrences. So this T4 here, the frequently occurring inamaanisha frequently bought. So inamaanisha kitu frequent inamaanisha you do the additions other than recreations. So if this I4, if we had another I4 that had proceeded from I1 before, then we could have just added that was okay. But we cannot recreate. You see, this one is going to form something from I1, yet I1 is also proceeding from another one. So these two, in short, this pattern here that you're trying to force is not recommended, because it's going to form confusion at the end of the day. That's why this item, we put it pending, because we might lose it. We might end up losing it if you're not careful. So when you now come back here, it's not easy to understand, I know, but the issue is we are looking at frequency and not explicit occurrences. When you look at transaction T5, I1, I2, I3, and I5, I2 we increment plus 1. Then I2, I1 will proceed from I2. Definitely we are going to increment I1 because it had already proceeded from I2. Then also let's look at I3. Definitely we are going to increment I3 because it had already proceeded from I1. So here it is, increased by 1. Then I5, I3. Remember, I3 will proceed from I5 will proceed from I3. We look at anywhere where I5 had proceeded from I3. So if you look at this, there is no place. I5 had already proceeded from I4. So we might add I5 here, which is allowed. But if we add I5 here, is it going to proceed from I2? Is there a transaction that has I2, I1, I3, I5? We look at. So I1, I2, I3, I5, it's transaction 5. So it is there. Let me see if, yeah, and you can see it here, hapa chini. Iko. Yes. So this transaction exists. So inamaanisha this root here also form another transaction T5. So we are right. Now let's look at the last one. Transaction 6. T6, I2, T6, I1, I2, I3, I5. The sequence will be I2. So we increment I2 because it already exists. Then I1, I3, and I4. So I1 proceeded from I2. We just increment because it already exists. I3 proceeded from I1. We just increment because it already exists. And lastly, I4. I4 should proceed from I3. I4 should proceed from I3, which had proceeded from I1, and you want to be very careful, and had proceeded from I2. But this one here, as you can see, is proceeding from I3, which had proceeded from I2. But the pattern we are being shown here is that I4, I2, I1, I3, I4. I4 should proceed from I3, which had proceeded from I1. So if looking at this, let me answer this little bro. Yes, Charlie, ni si unasemaje? So forming a tree can be somehow complex. Yeah. So in this case, we are allowed to proceed from I3 because I4 had to proceed from I3. This thing is becoming more and more complex. I2, I1, then I3. So the FP growth is saying that we can proceed from here and put I4 as 1. So that this one forms a database of T2, T1, T3, and T4. So this transaction 6. Aya. Let us go to the transaction T2, T1, and T4. That was transaction, the one you were asking. Transaction 4. I1, I2, and I4. So it had to be from, I think then it should work that way. I think this tree is wrong. So ours should work this way, the way you are suggesting. So that we have T4 here. Yeah. Because there is no harm. If you can put this in here, then there is no harm to put T4 here. So that it forms transaction 4. Because it is T4, T1, and T4. These are correct. The only violation that you should not ever do, you should not include a transaction that does not exist from the database. But this one exists. Yeah. Then we also had another transaction which had T4 and T5 alone. Transaction 3. So now you see, this one is not proceeding from transaction 2. So this one you are allowed to produce it from the child node, and that's why transaction 3, and it had just one. Item 4, it had item 4 and item 5. Then item 5 getting from item 4. So the root node from null, then we had another transaction. So at the end of the day, I think my nini was wrong here. The tree was wrong here. So we can, and I can remember drawing this tree afresh with another court, by the way. So at the end of the day, we have null, then I2, 5, I4, 1, and I5, 1. And this one was transaction 5. Transaction 3. The only thing that you should ensure that the transaction, all of the transaction occur very well in the database, and you should not bring up a transaction that an existing transaction, that is. So we also had another transaction, and this one was T2, T1, I2, I1, I3, and I5. I2, I1, I3, and I5. We also had another one, and this one was I2, I1, and I4. I4. Then we also had another one, I2, I1, I3, and I4. I4, 1, 1. Then we also had another one, I2, I3, I4. So this is our frequent pattern growth. Then you just fill. So they are well captured well now nicely. Yeah. Then what do you conclude from all that work that you've done? The lowest node item 5 is not considered as it does not have a minimum support, hence it is deleted. So the next lower node is I4. I4 occurs in two branches. And how? It occurs from I2, I1, I3, then I4. Again, I2, I3, I4. That one. Therefore, considering I4 as suffix, the prefix path will be. Okay, therefore, considering I4 as suffix, the prefix path will be I2, I1, I3. So I2, I1, I3. Why we are using the 4 as suffix? Because the last transaction here, I5, had been deleted because it did not meet the minimum support threshold. Meaning, here, not here, here. Meaning I4 is the last item in our tree. So that's now where we start now putting on. You remember now we are running away from transaction, but we now want frequent pattern item set to do the recommendation. So using this as the base, the first one will be I2, I1, I2, I1, I3. So I2, I1, I3. So these one are predicted to occur together. The next one, the conditional pattern base is considered a transaction database, and a fit tree is constructed. This contains I2, I3. I1 is not considered and does not meet the minimum support count. You also look at the database. The one that does not now meet the minimum support count, it is pruned off. You go that way until at the end of the day you will all realize that tuliadinga tukapata aje. If you go here, I3 were 3. I3 were 3, then I1 1, 2, 3, 4. I1 were 4. I1 4, I3 3. So probably this one was 2, while this one was 1. So this one would be 3. So anasema hapa vizuri that I1 is not considered as it does not meet the minimum support threshold. The one I'm talking about. How many I1 did we have proceed from there? So just one, but it meets. I think should be I3. It is just typing error. I3 is not considered, it should not be I1. And not any. So the path will be generated will be for I3, the prefix path will be I2, I1 3 times. This will generate a 2 node FP3. This is called. Then for I1, the prefix path will be I2. This will generate a single node. I2, I1. So here I3 is the one that is not considered and it is pruned off. Then the path that will be generated will be I2, I4, then I3, I4 too. So I mean this thing is very much confusing. Let us see the table. For item 4, conditional base is I2, I1, and I3. Conditional P3. Check it. Please, this Nini is misleading because I think I was basing my results on this tree. So let us use our own tree. First of all, we do away with I5 because it did not meet the minimum threshold. So the list one about I4, 1, 2, 3, 4 exists, and therefore we use I4 as the base. So the first frequent pattern is I2, I3, and I2, I1, and I3. I2, I1, and I3. Then we are done. Kisha, next one, if we consider a certain transaction here, we are done with I4. So we look at I3. I3 does not meet the minimum threshold here. So if it is true now, we remain with a single item set I2. And this is here. Then we look at I3, the one at 2 now. It means we shall have I2 and I1 if we remove this. So I2 and I1. So at the end of the day, when recommending for this specific client, we might recommend a combination of I2, I1, and I3, or a combination of I2 and also or just I2 and also I2, I1. So what product is predominant during recommendation? I2. So this is what we are going to recommend. Okay. So you notes inamaanisha iko na shida sana and I'll have to edit. So advantages of a fee growth algorithm. So which means you can recommend an item set of I2, I1, and I3, or I2 alone, or I2, I1. But at the end of the day, if doing a recommendation system, don't fail to recommend item 2. So you must recommend item 2 in every recommendation. Uh, so, okay. So advantages of the growth. This algorithm needs to scan the database only twice when or compared to Apriori, which scans the transaction each and for each iteration. Then the pairing of items is not done in this algorithm, and this makes it faster. The database is stored in a compact version in memory, and it is efficient and scalable for mining both long and short frequent patterns. Look at number 4. It is efficient and scalable, but it is very, very disadvantage is more cumbersome and difficult to build than Apriori. No one should be told that. Then it may be expensive, and when the database is large, hey, the algorithm may not fit in the shared memory. So when you compare the two, under characteristics of pattern generation, a peak growth generates pattern by constructing a tree, while Apriori pruning and forming pairs until you remain with the most frequency occurring. Candidate generation, there is no candidate generation, while Apriori uses candidate generation. The process is faster as compared to Apriori, but the runtime of process increases linearly with increase in number of item sets. In Apriori, the process is comparatively slower than Epigraph. The runtime increases exponentially with increase in number of item sets because you need to scan the database at each and every iteration. Then memory usage, Epigraph compact version of the database is saved while the candidates combination is saved in memory. So inamaanisha something Apriori it's more a lot of memory. Now, on top of these two association algorithm is this CLAT algorithm, which we are now coming to see how it works, though we not build a model there. So let's visit our Nini now. I don't know what's happening with my, to be honest, I don't know. It keeps on disconnecting. The how do you call it? Windows subsystem for Linux. Some notes here. The objective of this task is to build a recommendation system to identify frequent item sets and association rules. If a customer buys item A, they are likely to buy item B to enhance cross-selling for market share technology commerce platform. Dataset combined 2009 and 2010 transactional data with columns invoice, stock code, description, quantity, invoice date, price, customer ID, and country. So something that logically should know is that a single customer can have different invoices. So we are going to combine the invoices under his name and look at the quantity under such invoices. Then also, we are also going to find the description. Actually, I'm so much, I don't know, I'm not going to look at that again. Then the price and everything, then the country. Then the algorithm a priori will tend to find frequent item sets by iteratively generating candidate item sets and pruning based on minimum support. FP growth will use a tree-based structure for faster frequent item set mining suitable for larger data sets. This is wrong. We are not going to use when doing my research. I was told research CVs suited for supervised, so we need to remove it here. For hyperparameter tuning, we should use manual looping to minimize minimum support and minimum confidence for association rules. Evaluation, we are going to use metrics like support, confidence, lift, and conviction. In this case, we are going to use support and confidence. When you get a certain support from the looping, then you tend to say that 50 transactions. I'm helping a certain boy here doing that interinstitutional transfer, so I'm so sorry. The father is really piling a lot of pressure. And now, these family things, it seems as if I don't want to help because I'm done with food. Okay. Then the assumptions is that those are hyperparameters include the minimum support, proportion of transaction, the minimum proportion of transactions containing an item sets, which means that 0.01 means that 1% of transactions, 0.1 means 10% of transaction. This means that the minimum proportion of transaction containing an item set. For example, if you look at our example that we are using here, I want you to look at item set here I2 and I1, or I2 and I1. How many transactions contain I2 and I1? We have T1, T4, T5, and T6. That is 4 over 6, which is 67%. So that is what we call, we term the minimum uh, threshold, not support. That is the minimum threshold. The minimum support will now be 0.67 times 6. Yes. Then number 2, we are also going to look at the minimum confidence, which is the confidence for association, e.g. 0.5 means 50% of transactions with the antecedent also contain the consequent, meaning 50% of transactions will have the two occur, will contain the two as occurring item set. It's really nagging. I don't know what I did. It started in the morning. Yes, people, it's really nagging. Your task, please go and do more research on something called lift conviction. I didn't get into that, but I came across it as well. So as I do research from my end, that is your assignment. Also do research on something called lift and conviction. just have to close it now. I think it's just some bug, either in the WSL or Windows or VS Code. I don't know what is happening. Look at that. Man, that's how it keeps on behaving. And maybe it needs an update. So it is failing profusely. Okay. it will not force me to use Windows. You the Ubuntu one to just go. I install a new one. Yeah, sometimes, but you can back up. But sometimes life forces you to make a painful decision. So what is wrong? It's wasting my time. Unfortunately, the codes are not going to run because but I just want to explain. Okay. Now, we use a certain Python package called mlextend. So mlextend, we said if you want to know what the package does, the best way is to visit their documentation. So mlextend was used for association mining. So it's the one that contains both a priori and FP growth. So the GitHub pages, so you are able to read everything here. So it is also someone that gives a scaler a run for their money. Yeah. So as you can see, they also have linear models like logistic regression, support vector machine, classifier, random forest, ensemble vote classifier. They have a lot of other models apart from the ones that we want to look at right now. Yeah, so that's it. It was developed by someone called Sebastian Rashka. Yep. Then we also have a few examples here. One user guide. This was what I was looking for. Feature extraction, feature selection, frequent pattern growth. So if you click on this, you see association rules, P growth, a priori. So you can just come here and read a priori. The same thing with the frequent pattern growth. People are coders outside here, but then we also have association rules. FP growth. This one is FP. A priori is the one that has gone. A priori, yeah. So the association rules generation from frequent item sets function to generate association rule from item sets. So what we have been looking at in theory, the guy has come here and implemented it for us. So we just reuse this confidence A to C. You remember us looking this formula. So everything. So if you have some time, you might just want to come here and view and also see how transaction encoder, which you're going to use. So proposing you must import transaction encoder. So what does this transaction encoder thing that do? So this is definitely an information that contains, where is it? Where is it? It should be somewhere here. But what it's trying to do, it's trying to by force transform the data set to a certain frequency to actually look at as if it was a somehow frequency sets or not basically, it needs a data frame. How should I explain it? The data itself is a data frame of items. So transaction encoder is going to make it look as a transaction data set by putting in a set item set. Then these item set are the ones that are now being transformed to form a database, which a single cell can now have an item set. So you're trying to understand, like what I mean. If we have this transaction, a data set here, this a single cell in a containing one, scenario. But after encoding, you end up with a single cell containing a set now. So that is probably what transaction encoder is going to do. So we are also going to do it there, and as you can see, te.fit dataset, you also transform the dataset. Then you form a data frame from the transaction encoded dataset. Then the item sets with support. Look at this. You can also look at the association rules, the antecedents, the consequence. The antecedent is something that must be purchased by a person or the one that was frequently being purchased. So if a person purchases kidney beans, you would come. We had actually realized that you would also purchase eggs. And if you purchase eggs, you will purchase kidney beans, yogurt, kidney beans, eggs, and some onions, onion and some eggs. So you see that is this is what we call the association rules. How are items associated? Then you will come here and read more about this item from Sebastian as someone Ashka. So that at least you get to know more of association rules and everything. The overview here and the example and the API, which is not even there. Okay, then we come to FP growth. Let's start with a priori. You A priori uses the association rule mining based on pruning and iterating. So we have the data set, we encode the data set. After then encoding the data set, we end up with something like this, whether the item was contained or not. Then we come and look at the a priori, the item sets that were there. Then by default, the priori returns the column indices of the items, which may be useful in downstream operations such as association rule mining. Use the priori. Actually, what you are interested in is finding the item sets here. You see, let's now treat eggs alone as item 2 that we looked at when we were trying to draw FP tree. So then we look at this at the end of the day, and it's evaluated against the support threshold. At support of 0.8, we have eggs alone. At the support of 0.6, we have kidney beans. Then at support of 1, there is kidney beans, which means that kidney beans actually worked better for us. But we can settle for also eggs and kidney beans. So if you are going to use 0.8 and above, what should you not miss to recommend to a client? Eggs and kidney beans. So let's see how it's going to work. So the same thing for frequency, frequent pattern growth, which involves drawing tree, and after drawing tree, you find the item sets. So in our case, you've also, so you will come to this guide and it will guide you on how all these are implemented. Now here we go. We just import a priori and FP growth from frequent patterns. Then we also import association rules from frequent patterns. So which means we must generate association rules, then implement the algorithm on the rules. Then we look at the two data, we import them, then we concat them. And since we want since we are only interested in transactions, we are aggregating transactions into item sets. You group by invoice and customer ID, which means each and every customer ID per customer per his or her invoice. Then we look at the stock code, which means the specific item that the customer bought that is reflected in the invoice. Then you apply it as a list form. Then you reset index and name them items. So meaning everything that is going to be under transactions will be referred to as items. So we convert to one to encoded format. Okay, and one hot encoding. If it was one hot encoding, then I gave a wrong explanation. Remember what we said about one hot encoding? Each and every single item is evaluated to 1 or 0. So if it is 1, then it is that item. If it is 0, it is not that item. So the data set that we are forming here is a very large data set, a very large data set with each and every single item encoded using one hot encoding. Which means if I'm talking about a smartphone, if it is smartphone Infinix or 10, then that is 1. If we find another smartphone that is Samsung, then that is 0 under that column of. So the column name will be smartphone Infinix or 10. So anything that is really Infinix or 10 under that column will be 1, others will be 0. Sorry, hey, that one was so misleading. So the list that we're applying here that apply method applies a function. So the list that we are applying here is actually the list of invoices and customer IDs. So all these things that we've grouped, we are applying them as a list. And that's why you see, if you the list that is in here is actually a pre-existing Python class. So we are not mentioning ours. But more and more information have been well explained here. If you have time, you just come during your free time of explanation. You will just come and look at all these guys and see how they do their thing. And if you run into a problem, I really recommend going to YouTube. I have to be honest, I've never implemented this in production with Pgrowth, and I'm looking forward to implement it one day. Once you've encoded that one hat encoded, you now implement the a priori algorithm. Jesus Christ, can you just so that you can see the a priori frequent item sets? Then you look at the association rules from the a priori. Look at how it is encoded. It is implemented. You must put in the encoded data set with the minimum support of 0.01. Then use columns as true. Then we generate the association rules. Okay, this one is the standard one. But if you may like, you might use the for loop to iterate. Then we also have the generation rules. Then we save the models. The same thing for we now print the a priori minimum a priori frequent item sets. We can print them here. For a P growth, it's just implementing for P growth on the DF encoded with the minimum support and use column names. I really wanted to print that, but I don't know what is happening with my WSL. I really don't know. Let me see if it's going to work. So go do more research on this, Nini, on these two. Ah, it's going to open. Okay. Sudo apt upgrade. Maybe this might have been the problem. Yeah. Mm. It's not going to help me. Okay, but that is how these items are implemented. Then when you deploy it on a production environment, remember it's implementing it on a data set. So it means that the new data set that is incoming must have exactly the same structure so that these two models work. So what they do, they're just going to be recommending based on how the transaction history, how it is happening over and over time until you now find the best recommendation as data set grows. The larger the data set and the higher number of transaction and app use, the more robust your machine model will become. So let's see if it is going to open so that we can see. Pardon? Yes, yes, yes. The WSL actually. Mm-hmm. Calling, yes, bro. This thing is making us lazy. First of all, we have to accept that it is making us lazy, and it is making us actually forget about real life coding. And I'm very sure ningekuwa Jose wa kitambo sahii hata ningekuwa nimemaliza hiyo nini ya XAI, the evaluation of XAI job. But you see, I have to go back to the drawing board, learn Python from scratch, uh, and ensure that I'm well prepared, because the, the process, all the process will be monitored by a webcam. They will want me to be actually like in a production setup where they monitor my work and everything. So to answer you, it is not good, and it is high time an individual. It is high time an individual takes an initiative to ensure that you don't lose your skills. It was yesterday that I was reading through an on LinkedIn, an article. This guy was explaining well how what you guys feel like is helping you is actually destroying you. The likes of ChatGPT, Gemini, and he was not talking it in the sense of tech. He was referring to it in the sense of now the real world communication systems process. Like a person is literally going to the site, copy pasting all what ChatGPT has given, including if you need other things I can also recommend. You like that's last text that the AI will tell you. Then he forgets to edit and paste to an HR, then expects to find to get a job. And if you look at this person, he has 7 years of experience in the field, meaning this guy was working before this ChatGPT thing came. So the guy was asking, how are you doing things back then that you cannot do right now? So it's going to be a challenge, a very big one, but it's upon individual. Look at what I'm doing right now. This, by the way, I might know how to explain the codes. You might get the concept, but it's not right. The best way was to write the codes, not rely on AI generated code. So this thing came to help us, but we are misusing it. We are giving it. It is not helping us. We are helping it. Yes. So the ball is on us. Well, there are robust models like GPT-4. Oh, they have tried, but they have not. Actually, last year there was this one called Stephen or whatever. That from it was from Japan or something. That it was able to generate an entire software. So where did you see that? It cannot. To answer you, it cannot. It will give you the codes which you can copy paste, but at the end of the day, you must do some tracking, even if it's a little one. But it will not build an entire system. If it was to build an entire system, then it means that my market share will not take 6 months to build. So it will not build an entire system, but it really helps a lot. It reduces the time through which a system can be built. Right now, you see, a company can just set a target that 40 years, something that was being built in 4 years can now be built in 6 months because of AI. We accept that one is there, and it also helped me a lot. I write codes, and if the codes are not well in me, I just I write code, and if the codes are not uh, getting to what I wanted, I copy them to AI, and the AI refines them for me. Or I have an idea, I don't know where to start because I'm not proficient in JavaScript coding. I just tell the idea the prompt, tells it what I want, then the AI will generate the codes for me. So it helps, but we are misusing it. Yes. Mm. I think upgrading has resolved it, but let me wait and see if it's going to. Pardon? Yeah. In fact, there will be a lot cause AI is going to increase it. Contrary to what people think that it is going to reduce it. The only thing that is going to happen, entry level roles will be overtaken by most entry level roles will be overtaken by AI. So when you're hired as a machine learning engineer, most of the things you're going to do is just to refine AI generated codes. And I think most companies have, and I love them for doing that. They have started being honest in what you're going to do, and I really love it. If they, I saw one by the way, and I was so thrilled, and I was like, "This is so much okay. It's good." Your task will be to review most AI generated codes and also advise on the use of AI. So you see, that's a company that knows what you are going to do and knows the impact of AI on its operations. It's taking time. Now, AI was there to help us, but we are the one who are using it wrongly. This thing should help us, literally. Very true. When it first came, when Google first came in 1998, people were like, Google is going to take our jobs. 27 years later, what has Google done in the tech space? Create a lot of very many jobs. AI, people, when ChatGPT came, AI is going to lose our jobs. Do you know that US alone, the jobs have increased by 45%? Why? Because people want to counter ChatGPT and they want to develop their own AI. So when they develop their own AI, they have to hire AI engineers. When these AI engineers come on board, uh, this system must be maintained. This system, when it is being maintained, it is generating revenue and it is growing. It means it needs more AI engineers. So at the end of the day, yeah, so there is nothing like AI is going to take our job. It will not. In fact, it's going to increase our jobs. The only thing you need to do, you need to up your game, stay ahead of the rest, and ensure that you have short professional courses so that you apply for senior engineering roles. But the entry level roles are going to be a bit challenge. I have to accept. But at the end of the day, even the senior engineer must have a junior person must have a junior person working by his side so that to explain more and more or to help when he's not away. So it's not going to take in our job like entirely. No. Yes. Mhm. Yeah. Hmm. Yeah, so that the ball is on you because now you are at a high advantage because you also have the architectural skills with you, which for us we lacked, and that is how machine learning came about. Because before, there were, do you know what used to happen? The the statisticians or mathematicians used to work hand in hand with computer scientists who are basically in more into coding. But around 2008, the business has shut down. The likes of IBM, Amazon, they sat down and asked themselves, no, if these people are working together, why can't we consolidate this one scale to be for one person? I mean, there is no need of having a statistician and at the same time a computer scientist. And a computer scientist, for him to build a machine learning model, he must get skills from the statistician. So why can't we come up with a certain fancy field? And that's how the science came up. So I'm just trying to answer you. Maybe one day we might have architectural science. Maybe you never know, or because of what you invented. That is one. Another thing is the same thing with the likes of QuickBooks, the accounting software. It was also an idea of an accountant. So when he learned coding, it was like, I think this one can streamline accounting. Yeah. So I hope I have answered that. This one is going to take forever. I don't know what's not happening. Hey, we are back at the same problem. I don't know what the problem is. Literally, I don't know. It keeps on doing this way. So I don't know. I don't know if the problem is in VS Code or the problem is in Windows subsystem for Linux. I really don't know. You see, this is how it behaves. Okay, I'll send you the files so that you just copy the codes because at this juncture we need to stop at that point. So I'll rely on you to tell me if yours has successfully run. Okay, how many recordings by the way so far? 9. Like I'm in a lot.